The RP2350 and Raspberry Pi Pico 2 are faster than its predecessors in terms of clock rates, the core design itself, and with some accelerators. How does it compare against the RP2040 and the Pico? Well, for some of my use cases, let me tell you how. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, robotics, IoT, and other fun tech. Remember to subscribe and join the community. This is my 3-minute summary of my RP2350 and Pico 2 performance tests. If you have time, why not check out the full video? I've previously looked at the performance on the RP2040 and Pico 1 by calculating the value of pi to 1,000 decimal places. I'm going to extend that to run on the Pico 2. This uses an existing template library to do the calculation. I have the test application to run this on one core and then both cores of the RP2350. A single core on the RP2350 is faster than both cores combined on the RP2040. In dual core mode is more than twice as fast as the RP2040. This is much better than I expected, but why? Well, the RP2350 is both clocked faster and the Cortex M33 design is significantly faster. This is for largely integer arithmetic. How about the floating point? Well, the RP2040 used just an inbuilt software library for floating point calculations, whereas the RP2350 now has dedicated floating point unit and registers associated with each core. To test this, I measured the number of times I could do a forward kinematic algorithm on a robot arm in 10 seconds. The RP2350's hardware floating point accelerators is more than 3 times faster than the RP2040. If I drop back to a software implementation of floating point and not using the hardware, then it's only twice as fast, much like the integer arithmetic on the pi calculation. The RP2350 and therefore Pico 2 is significantly faster than the Pico. In these use cases, the RP2350 on a single core is faster than both cores on the RP2040, for integer arithmetic anyway. And the floating pointer unit is 3 times faster than the 2040. Floating point arithmetic is something that's not traditionally done on the microcontroller, as they're generally considered too slow. But the calculation rates here are actually quite good for doing a forward kinematic algorithm. I think I can start to push some of the planning and positional algorithms for my robot arm down onto the RP2350 to calculate. If you like this video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video. Remember, I'm saving these up to get myself to open source in San Francisco next year, and I'd appreciate your help in getting me there, and I hope to see you there too. Thank you very much for watching. If you enjoyed the video, then please hit the like button and please subscribe to my channel so you don't miss the next video. Bye bye for now.